we'll take these up, okay? I also gave you a sheet yesterday, like the homework questions or like practice more factoring questions for you guys to work on. That kind of like broke down each of the forms, so it kind of was nice, right? So the first one, what would we consider the first one as being? What style of factoring? If I had to give it a name or like a method, what do I see? I see a difference, subtraction. So I'd say a difference. And then there's two squares sitting there, right? So it's a difference of squares. That's how we get the name, right? And then so for me to do the work on this, right? Difference of squares is really, really easy. I can just go like square root the first, square root the last, right? So I get x and 2, but I have to write it twice, don't forget, right? Because I'm going to get two factors. And then anytime you see a minus sign in the middle and no b term, right? So there's, if I'm talking about y equals ax squared plus bx plus c, I don't see a b term or bx, right? The only way for that to happen is if the two numbers for man are of opposite sign, right? Well, a -2 and +2 in this case, right? That's you done. That's difference of squares. Square root the first, square root the last, write it twice, and then have opposite signs between them. That's difference of squares. It's an easy one. Okay, do we have any questions about that one? Again, a lot of this comes down to recognition, right? And the sheet I gave you yesterday it breaks it down nicely because each of the factoring types is its own section. So you get practice doing a whole bunch of the same thing. And then you associate a name with the process, right? What about the second one? What's it look like at face value? How many terms? It's 3, right? Looks like 3 terms. So you might think, oh, and then the a value is in 1. So you might think, oh, it's a complex trinomial. I would have fooled you if you thought that, right? Because you can take the factor of 2 out, which is what I told you to do always. If you can do it, take it out. So it's to take out the greatest common factor, and then write what's left after you do that. Plus 2x minus 35. I think I saw a few people just stop here, right? That's not fully factored, because now I have a simple trinomial on the inside. So I can go, okay, I need two numbers to multiply to -35, but also add to 2, right? I know that's the case because I go like, it has to multiply to this number and add to that one up front. Right? So with that, now I'm stuck, okay, well I gotta figure out what the two factors are that satisfy both of those conditions. That's where I'm at, right? So let's go, okay, 1 and 35, not gonna work. 2 doesn't go into 35. 3, 7, and 5. You just keep going, right? So it's the two numbers that would work would be 7 and 5, but then I need them to add to 2, but also multiply to -35. So one of them has to be negative, yeah? -5, right? Right? And so now that this is a simple trinomial, I told you for simple trinomials, so where there's a value of 1 out front, you can take two factors, whatever they are, and you write the variable to the left of them. So by that I mean x plus 7, x minus 5. Okay? The complex ones are different because they're called complex trinomials. You can't do that. Simple trinomials are simple trinomials. The process should be easier for them. Does that make sense? Good so far? Okay. So there's two types so far that we've done. and maybe 3 if you count the greatest common factor as one of the factoring types. Okay, what's this? So I'll do C. Okay, what's the value out front? If it was 0, there would be no d squared term. So just be careful, right? So it's just 1, which means it's a simple trinomial. Right? And now, so it's the exact same as the last question, just without the 2 out front.
What is B called?
B is, what do you mean B? B like in...
Like difference of squares.
Oh, sorry. This was like, I see what you're saying. We could call this like you want to call it a hidden, this is me making this up, a hidden simple trinomial. Yeah. It's the word I'm using the word hidden because there was a GCF in there. The hidden simple trinomials?
Yeah.
Have you ever been in the bit?
Yes, many. So many.
Okay, so this one we got simple trinomial, right? So, and remember what I said, the multiply, so when I fill out this MAN or the MAN method, the M is always the A value multiplied by the C value, right? So in this case, it's 1 times 16, so the multiply is 16, and has to add to -8. Oh boy, look at me go. We're going to have to change the name of this one. I'll change the name after. Let's do this question as if it's a normal question, though, as if it's a simple trinomial. And I always do this, so this happens all the time, right? Because you get caught up in doing the processes, and you forget to check stuff. Yeah, Ian. You could, but then that would make it so you could do this question like that if you wanted to, right? You want to multiply to -140. Do you want to do that? I don't want to do that, right? When you see big numbers like that, that's got to be your clue to like pull out the greatest common factor, because that's not nice, right? You're going to be... I could do 10 and 14, 10 and 14, right? So it'd be exactly 10 and 14 would satisfy those two conditions, right? Which are conveniently twice this. So you're always looking for that GCF, right? It's a good question. Okay. It's not that it won't work. It just makes, now, if you don't take that common factor out, now instead of just being able to write this answer, you got to do decomposition of the table method, right? Because it's complex. You don't want to do that. That's your last resort. You want to use a different method before complex trinomials. So if you can make it a simple one, that's what you're going to go for. Okay? Is that good? Okay, so the next one, again, this is me like, we'll do it the normal way, and then I'll show you the easy way.
Could we not do -4 and -4?
Yes. So again, like I get kind of caught up in just doing things sometimes, and because I'm such a process guy, right, that I forget to think. Right? Well, let's do it this way first, because it's a good lesson. Okay? So I need two numbers to multiply to 16 and add to -8. Yes. Sure.
-4 and -4.
Okay. So because it's a simple trinomial, right? You did have it right. Maybe, I don't know. I can't see your sheet. But let's go. So once I get those two numbers, I can just go d minus 4 multiplied by d minus 4, which is equal to d minus 4 squared. Now, that's if you just factor this as a simple trinomial. But there's something special about this one, isn't there? Both those numbers are the same. What did we call these when both the numbers were the same?
Perfect squares.
They're perfect squares because the length and widths are the same.
So you just cross it.
You can, yeah. It is a form of a simple trinomial, right?
Because you can still solve it.
Yeah, no, you can call it a simple trinomial if you want. It's a special form of a simple trinomial though. Perfect square trinomial. Now how do we do the work for that? Do you remember? I'll do it in blue so you can see the differentiation. What did I say to do right from the get-go? Square root the first, square root the last. Take the sign from b. What's the square root of d squared? D. What's the square root of 16? 4. Take the sign from b minus.
Wait, it's that easy.
Yep. It's about recognition. It's 100% about recognition. See, you can't. This is what I'm trying to promote, right? And I'm bad at it too, is just get into the processes of doing things like the same way every single time. You forget to think. Check things. That's the exact same thing as trying to do this way, right? Multiply, you forget to check for the greatest common factor, and then you're doing more work than you need to. It's identical to this. Look at how much work I did here. Relative to all the writing in the black. Way more thinking going on. You don't need to do that. It's a perfect square trinomial. You need to identify it as such. Okay. Next one. We good? Do we have any questions about that one? Okay. Let's do the next one. I see. This one's a little bit tricky. I think this stumps some people. Okay. I see two pieces. Right? This is very similar to decomposition when I showed you this. I see two pieces. I also see something common amongst both pieces. I have x plus 6 in both pieces. So it's no different than a number. I'm going to this is what I'm going to do. I'm going to take the piece out, the piece that's shared between number 1 and 2, x plus 6, and then I'm going to write what's left after I take it out. What's left? 2 minus y. Done.
It's that easy.
Yes?
So you literally.
There's nothing else to be done.
So,
Yes, Aiden?
You put the that's like 2 inside the bracket. You always put that this way.
You could put negative y plus 2 if you wanted to. I just like reading things. Is that what you're asking?
Yeah.
Yeah, I just like reading things left to right as they are.
So you would mark the same. Like
Yep. It means the same thing, right? So it's no different than if I asked for 2 minus 1. You'd be at the same answer either way, right?
Yeah.
Does that make sense? All right. Let's do the next one. Well, what's that called? That's maybe even common factoring. We could call that one common factoring almost. Okay. All right. Here comes a tricky one. I don't know why. Oh no, it's not that tricky. How do you want to do this? Is it hidden simple? Is there something I can pull out of all 3 of those? To
Or 16x
Oh.
squared and 25.
square root.
who wanted to use man?
No one.
No one.
First you have to.
No one wants to use man.
First you have to do the other thing and take the.
Again, it's about identification. Square root the first, square root the last. Take the sign from b. 4x and 25, right? There's going to be two of them. What's the sign on b? Negative.
4x and 25.
Sorry. Square root of 16x squared is 4x. Square root of 25 is 5. The sign from b comes down, and I have two of them. Much easier than trying to go multiply to 16 times 25, add to negative 40. Good luck.
Wait. So where does the negative 40x go when you square root 16x squared and 25?
Ask that again.
So you just have a negative in a place where there was negative 40x. Where does that go?
So if I were to write this, I'll do the opposite process now. You guys watch, this is a good question. Where'd the negative 40x go? Seems to have disappeared. Maybe I did this wrong. We'll find out in a second. Do you agree with this, that this is the same thing?
Okay, add
What adds to 40?
4x times 5 times
Let's do the expansion, Jessica. Shall we? 4x times 4x, 16x squared. 4x times negative 5,
20, or negative 20 squared, and then,
x squared.
or sorry, x, and then
Okay.
it's gonna do the same because you have, and then 25. Okay, that makes sense. Thank you.
That's how you know you're right. Always. Always, you can always check your answer with this. And if you really wanted to prove yourself and go over the edge, you could complete the square on that and write it in vertex form if you'd like. All three forms of the parabola should give you the same. You did do that, actually, funny enough. I didn't think about that.
No, I'm fine with pencil correct.
No.
Okay, last one.
No, give it to him. Start. No.
What's this? It's a tricky trinomial.
Wait, did I get the right answer and then do the thing?
Huh?
Did I get the right answer and then go through and complete the score?
I don't know. I haven't looked at it. I have to look at it. You could make the argument you were just proving your answer.
True.
It's a tricky trinomial, this one. F, or a complex trinomial. I like calling them tricky trinomials. Tricky tries. They're funny. They're fun to say, right? They bring a little fun to having to do complex trinomials and table box method. Fun. You get to say tricky tries. Okay? So they got to multiply to what? 2 times 3. They got to multiply to 6. And add to 5. Okay? What are the two numbers that make that work?
3, 2. 6 and 9.
Okay, 6 and 1 would be my starting point, but then I'd be like, okay, I can't make. Oh, good.
6 and 9.
Let's do it. Is it? Which one is it?
It could be 6 and 1.
Can it?
Yeah.
Let's fine. Let's start. Watch. Let's start. That's fine.
Oh my
1 and 6, right, Aiden? That's what you're saying.
Yeah.
You want to make the one negative?
Oh, negative.
What's that? Yeah, it becomes negative 6.
Yeah.
That's a tricky question. This is silly, tricky tries, right? What's next? That's not gonna work. We'll go to 2. 2 times what? Yeah, Hunter.
Just 2 times 3.
2 times 3. That checks out the conditions, right? Okay, that's fine. What do I have to do next? Am I just going to throw the variable? Am I going to do this? Am I doing that? It's too easy. There's nothing easy about tricky trinomials. You should at no point feel like that was too easy, right? Right? What do I have to do?
The thing with the middle where you. Yeah. Not completing the square.
Not completing the square. We're going to fill out the table, right? So let's write everything I have on the inside, right? So the 2x squared goes here. The 3 goes in the bottom right. And then I break up. I find the two numbers. So 2x goes here and 3x goes here. And then I read off the sides. Let's read horizontally, shall we? What's common there? What's common amongst the top? Okay, you could do the bottom. Do 3. 2x in the top. Forget about the signs. We'll do the signs after. Aiden, what's common here? See, let's go. Come on. What goes there?
Oh, okay. You got 2x.
Yeah, what's common on the blue?
Yeah, 2x.
Right here? Can you take a 2 out of 3?
But now I'm just left.
Can't take 2 out of 3, right?
So just x.
Just x. And what comes here?
Or is that the same number?
Yeah, you can't just, yeah.
Okay.
Whatever the greatest common factor is, right? So that's a combination of the number and the variable. So with this one here, the 2x and the 3, not a lot going on there besides 1. Right? Now I have to fill in the inside of the table to get the signs, right? So I'm going to do the signs last. Now the nice one about this is everything's positive, so there's no negatives in here. So your factors are going to be 2x plus 3 multiplied by x plus 1. That's your answer. Okay? Any questions?